This is going to be a flip video about balancing chemical equations. So in order to begin talking about balancing chemical equations, you need to remember the law of conservation of matter. And the law of conservation of matter states that matter is neither created nor destroyed, meaning if I start off with a certain number of atoms, I should end up with a certain number of atoms. The only difference is that when a chemical reaction has occurred, my atoms have rearranged to form something new. But even in that case, what you start with, you should still have the same number in the end, just a different combination maybe. So let's take a look at this really easy example here. It looks like I started off with two atoms connected here, two purple atoms, and a single green atom here. And a reaction takes place. These reactants react to produce something new, a new combination. It looks like the purple atoms have broken apart. And now one of the purples has bonded with a green, and the other purple has been bumped off. So this is a chemical reaction. New stuff had been made. The law of conservation of matter says that if I start off with two purple, I should still have two purples somewhere in my products. Doesn't matter how, but somewhere. They could change state of matter. They could change formation. And if I started with one green, I should have one green somewhere on the other side. This is what we're going to be doing today. We're going to be balancing equations so that we can obey the law of conservation of matter. That's what we do to balance, to bring back as many atoms as we need to balance it out. So let's take a look at a popular equation seen here. This is a chemical equation starting with my reactants, hydrogen and oxygen, reacting to form water. So the first thing we want to do is we want to take inventory, which means we want to count our atoms. So we're going to create this inventory chart seen here. R stands for my reactants, P stands for my products. In the middle, I'm going to list all the different types of elements I have. I have hydrogens and I have oxygens, nothing else. Now I'm going to take a basic inventory before I begin. I have two hydrogens seen here on the reactant side. I have two oxygens seen here on the reactant side, R for reactants. On the right-hand side, which is the products, P for products, I have two hydrogen and only one oxygen. All right, so from the get-go, it appears that my hydrogens, while they are balanced, my oxygens aren't. So I'm going to start with my oxygens and try to balance them. And the way to balance them would be is if I had another oxygen. So I'm going to turn this 1 into 2. So I'm going to look at my product side at my oxygens. Here they are on my product side. There's my oxygen. How do I turn this oxygen into 2 oxygens? Well, there are a few rules you need to know. And those rules are this. You can only add big numbers in the front of each substance. We call these coefficients. You can only add big coefficients in the front. Notice I put a little empty space for you, a line to indicate and show you here, here, and here. The line is the only place where you can add things in. Okay? So what you should be careful of then, that means you cannot change subscripts. Okay? You also cannot add a subscript or remove a subscript. So no touching the subscripts. Leave them alone. And lastly, a popular thing some students like to do, let me push this up here so you can see what I wrote. Cannot change subscripts. You cannot add or remove subscripts. You cannot add a coefficient in the middle of a compound. Okay, So what that means is if this is my compound right here, water, I can't just stick something in the middle of the compound. That would be weird. All right, so what can I do? Again, I can only add big coefficients in the front. So let's take a look back at our inventory chart. We were going to change oxygen. How do we balance oxygen? Well, we said we wanted to give this water molecule, we needed 2 oxygens here, so I'm going to add a 2 in the front there. Again, you can only add here, here, or here. So now I need to retake inventory. Always retake inventory when you've changed something. I changed the products, I have to retake inventory for my products. I now have 4 hydrogen. That's okay. I know you're thinking that threw it off, but that's all right. That's what happens. And now I have 2 oxygens. Okay, while my oxygens are balanced, my hydrogens got thrown off. That's the way it works. Sometimes it throws things off. So now we have to go back and balance the hydrogens. So I've got hydrogens over here. There's 2. How do I make this into 4? Hopefully you said add a big 2 in the front. 2 times 2 give me 4. And let's check. 4 here, 4 here. Correct. 4 and 4. 2 oxygens here. 2, this 2 gets distributed. Oxygens here. 2 and 2. Good. Balanced. Everything is balanced. This would be considered a balanced equation. Now I know what you're saying. Is this empty? Is that a 0? No. That just stays as an invisible 1. As an invisible 1. Okay? Invisible 1. All right? Good. Let's go on to another example. Let's take a look at aluminum reacting with chlorine to yield aluminum chloride. All right, let's take inventory here. R stands for reactants, P stands for products. Let's move this up. Put our elements in the middle. I have aluminums and I have chlorines. 1 aluminum on the side, reactants. 2 chlorines on my reactant side. 1 aluminum on my product side. 3 chlorines on my reactant side. Now, I notice my aluminums appear balanced, but my chlorines don't. So a good trick is to say 3 and 2. What's a common multiple between 3 and 2? Hopefully you said 6. How do I make this into 6? Well, 3 times 2 would be 6. So I need 3 times as many chlorines on the left-hand side. All right, let's put that in. 3 times 2 is 6. Change your inventory chart or else you're going to lose track. Did I change anything else? Nope, not yet. But I need to make this into 6. 3 times 2 should give me 6 on this side, hopefully you said. So let's put that here. 2 times 3 gives me 6. I change this. Okay, good. My chlorines are balanced, but careful. Remember, anytime you put a number and change something, you have to take inventory for everything that it affects. Now I also have 2 aluminums. 2 aluminums. So on the product side, I have 2 aluminums. I have to balance my other aluminum. So sometimes this happens. I balance one thing and I throw off the other. That's all right. How do I balance this? Add a 2 there, big 2 in the front, retake my inventory, and now I have 2. Let's double check. 2 aluminums, 2 aluminums. Correct. 6 chlorines, 6, 2 times 3 makes 6 chlorines. I'm all good. 2, 6, this balances out. All right. And let's move on to our last example, which is a little bit harder. Take a second, maybe pause the video and copy this one down. All right. In this example, I have calcium phosphate reacting with sodium chloride, also known as table salt, to produce or to yield calcium chloride and sodium phosphate. If you notice, phosphate is a polyatomic ion. Phosphate and phosphate. All right, let's push this up here and let's begin. Here's my inventory chart. Wow, I probably really needed inventory chart for this because there's a lot going on. Notice I've inserted for you the places to remind you where are the only things you can do or you can add in order to balance. Only big coefficients. All right, so I've got calciums, I've got sodiums, I've got chlorines. Now, if you see a phosphate group on both sides and they appear the same, PO4, PO4, then you can balance it as PO4. If not, if they did not appear that way, then I'd have to actually create an inventory chart that made them separate like this. I have to break apart the P and the O to count them up. I can always break them apart because this is just counting atoms. But to make it easier, I'm going to keep it intact. And the reason why is because I see it exactly on PO4, PO4 on both sides. Okay? So I would have to do it this way if that was not the case. If this was PO4 and this was PO3, then it doesn't work. Then I'd have to divide them up into P and O to count the atoms. All right. There's 3 calcium atoms here. Let's take some inventory. There's 1 sodium here. There's 1 chlorine here. I have 2 of these PO4s. 2 of these PO4s. Right? 2. Okay, on the right-hand side, I have 1 calcium there. 3 sodiums there. 2 chlorines there. And just 1 of the PO4 groups. All right. Wow. There's a lot that's not balanced. That's not balanced, that's not balanced, that's not balanced, and that's not balanced. So where should I begin? Well, you really can begin anywhere you feel comfortable. There's no real trick to this. I personally like to balance my big groups. I call this a group. Okay, what was once a polyatomic ion, I like to balance the polyatomic ion because it's a little easier to do. Okay, let's say you didn't begin there, and let's say you tried to balance somewhere else. Okay, like for example, let's say you thought, I don't know, let's balance the sodium first, or the calcium first because you liked calcium. Okay, let's try calcium because it's the first one and see what happens. If I have 3 calciums on this side, I'm going to add a big 3 to put my calcium there. Let's see what this does. Remember, take inventory again for anything it affects. On the product side, I affected my calcium and my chloride. 3 times 2 is 6. Okay? Now, because I affected my chloride, I don't know, what if I decided to go ahead and balance my chlorides? 6 chlorides there. So, 6 chlorides here, now I added 6 chlorides there. So now I fix this side, 6. Now I have 6 NAs. Alright, did I affect anything else? No. Good. Okay, well since I have 6 NAs here, let's fix this NA here. 3 times what will give me 6? 3 times what will give me 6? Hopefully you said 2. Alright, so far this looks like it's working out. 3 times 2. Right? Good. So that gives me 6. 3, 3, 6, 6, 6, 6, 2, 1. Not only do I have 6 sodiums, but this 2 also goes to my phosphate. So now I have 2 phosphate groups. 2 phosphate groups. 2 phosphate. I already had 2 to begin with. So it appears like I'm balanced. Let's check. 3 calciums, 3 calciums. Good. 6 sodiums, 6 sodiums. 2 times 3 gives me 6 sodiums. Chlorine. 6 chlorines, and 3 times 2 gives me 6 chlorines. Good. Phosphates. 2 phosphates and 2 phosphates. So far, great. Or actually, I'm done. Perfect. That was great.